Alright, so in this particular mole conversion problem, the question asks us what is the mass of 60.2 times 10 to the 23rd molecules of potassium permanganate. Okay, so here it wants us to find the mass given the number of molecules. So according to this particular flow chart, we're given molecules and it wants mass. So here's our starting point on the left side for this particular problem. Why? Because it gives us molecules, so we got to start with molecules. And then we got to go to moles, and then from moles we got to go to grams because the unit for mass is grams. So this is a two-step problem, excuse me. Okay, so I'll take it one step at a time, and then I'll show you at the end. You can do it all in one step if you choose. So pick a strategy that works. If you need to chunk it down, chunk it down. If you can do it all in one, do it all in one. Okay. So here's the periodic table. Let's go and identify our elements real quick. We have potassium, we have Mn, and then we have O4. So I'm just going to highlight these on the periodic table here. This way, you know what the mass is as you find the molar mass. All right. So the first thing I like to point out is that potassium permanganate has only one potassium. Here's the one. So I identify there's only one K. So there's only one K here. And the molar mass for K in the periodic table is 39.098 grams. However, there's only one Mn. Okay, so therefore, I'm also just going to go ahead and identify there's only one Mn, and then the molar mass for Mn is 54.938, which is right here in the yellow. And then if we go to O, I do want to point out that in this particular formula, potassium permanganate has 4 oxygen, so there is a subscript 4 at the very end, so pay attention to subscripts in the formula. Okay, all right, so here in the next one there is a 4 in front of O for oxygen, and then you notice here because there's 4, I'm just going to multiply the molar mass of O by 4. So if you do 4 times 15.999, and that'll give you a molar mass of 63.996 grams. Okay. All right. Now to find the molar mass of potassium permanganate, all you have to do is add all these values up. So if you punch in your calculator, 39.098 plus 54.938 plus 63.996, and that is the molar mass of potassium permanganate that you need. All right. So the first step is to go from molecules to moles. So I'm just going to knock this out real quick. I want to start with the values given in the problem. It says 60.2 times 10 to the 23rd molecules. So I'm going to put that over 1. And the next step I'm going to go is from molecules to moles. Okay. So therefore, molecule needs to go on the bottom. So you need to use Avogadro's number. So 1 mole of anything has this many molecules or atoms. In this case, we're given molecules, so we're just going to go ahead and set up Avogadro's numbers in terms of molecules. So Avogadro's number is 6.022 times 10 to the 23rd. The unit here is molecules, and then that makes up 1 mole. Okay, and that's what Avogadro's number tells you. 1 mole of anything is 6.022 times 10 to the 23rd of whatever it is that you're talking about. In this case, it's molecules. So let's go ahead and cancel out molecules because the units here, top and bottom, cancels out. So the first step is done. I do want to point out for this particular problem, I noticed this is 10 to the 23rd, and then here, let me take my arrow out. I noticed in the scientific notation has 10 to the 23rd, right? You multiply them by 10 to the 23rd, but Avogadro's number also has times 10 to the 23rd. So for this particular problem, I noticed these are the same. So I'm just going to go ahead and actually cancel them out because you have 1 on top, 1 on the bottom. You don't have to. I just noticed that for this particular problem. Okay, so if you need to, punch in your calculator. So if you punch in 60.2 divided by 6.022, you should end up with about 10 moles of potassium permanganate. All right. Yeah, I think you get like 9.99996 or whatever. I'm just going to round up to 10. And then from here, now that we have moles, we can go from moles to grams. So in my little animation here, now that you've gone from molecules to moles, you're not done yet because you're trying to get all the way to the right side. So now you got to go from moles to grams. So I'm going to start with moles that I just previously calculated in my first step. Okay, so I'm going to set up 10 moles of potassium permanganate. I want to put that over 1. Except now I got to get rid of moles. So to get rid of moles, it needs to go in the denominator. So 1 mole of potassium permanganate has 158.032 grams. As I said earlier, if you watch my cursor, if you punch in 39.098 plus 54.938 plus 63.996, you should get 158.032 grams. Okay, moles gonna cancel out. So right now, the only unit left over is grams. And if you simplify this on your calculator, well, here you're just multiplying by 10, right? So I don't think you really need a calculator for this one. This is 158.032. Well, multiplying by 10 would just shift the decimal one space to the right. So that's up to you if you want to punch in your calculator. But the answer is going to be 1,580 grams of potassium permanganate. The problem starts with 3 sig figs, 60.02 in scientific limitation here. So I'm just going to leave my answer here in 1,580. The 0 is not sig fig or significant. So it's just 1, 2, and 3 sig figs if your professor or teacher is going to know about sig fig. All right, other than that, that is how you do it for that one using a two-step strategy, right? From molecules to moles and then from moles to grams. However, if you want to just knock it out in one scoop, you can. Here's my work. You can start with molecules and then cancel out molecules just like I did, and then cancel out moles. So as long as you place these conversion factors appropriately in each of these steps, you will always get the right answer. So molecules will cancel out here, and then moles will cancel out. Once again, the only unit left in this line is grams. And if you multiply across 60.2 times 10 to the 23rd times 158.032, and then you're going to divide that by Avogadro's number. So I would encourage if you need to use parentheses in your calculator. This way you don't get a jacked up answer. Okay, but as you can see, the answer here will come out the same. All right, I hope that helps. Stay nerdy. Don't be whack.